All right, second section, we're going to talk about quantitative data, and we're going to look at ways to graph them. In section 3, we'll talk about numeric values that we're going to get on. But again, difference between quantitative and categorical. Categorical, we would respond to something using words, color of a car, again, gender. Quantitative, we're able to use numbers. Okay, so GPA, speed, okay, height, things like that. But again, one of the ways that we know we can also have quantitative data is that I'm able to do math stuff with it. I can add, I can subtract, I can multiply, which is going to help us when we get into the third section. So just like in categorical, what we want to number one do is be able to look at a display. One of those ways we can look at it is a dot plot, or also called a line plot. Okay, line plot a lot of times because what we're doing is we're going to put the stuff on the number line. And so what I'll look at is what's my smallest value and what's my largest value. So I'll put each of those values then on my number line from my smallest up to my largest. Okay. And the process goes is that what I'll do is each observation, what I'll do is I'll put some type of a mark above that observation. Okay, so I'll put an X or a dot. Sometimes you'll see dots, but I think that's kind of hard to tell once in a while. And so I'll just go through my list, and everywhere I see, or every observation, what I'm going to do is put a point on my number line. And so then what I'll do is I'll see what's going on with my data, where most of my data lies, and so on and so forth. So that's how you'd make a dot plot. Second type we're going to look at is a stem plot, or a stem and leaf plot. Because what we have here is my stems. Okay, we think about it as a plant. You got your stem, and coming off my stem are my leaves. Okay, so what we want to look at, again, a couple of things. Our leaves, the rule is going to be as one digit only. Okay, that's going to be one of the things. So one of the things you could do is you could go through and put your data in order, and we could do this in any situation that we encounter. But I'm going to look at kind of when I did the dot plot stuff, look for my smallest. Okay, and look for my largest. Now, if you notice 4 to 35, that's a lot of values that I would need to put on a line plot. That's why that's not a good way to display this data. But what I'm going to do is make sure they both have the same number of digits. Okay, so they're both going to be 2-digit numbers. Now, what I'm going to do is I'm going to cross off that last digit. Okay, and so then my smallest number remaining is 0, my biggest is 3. And so that's how I'm going to decide what my stems are. And what I'm really going to do then is go and do that to every one of my numbers. So 14, I'm going to cross out the 4. That 7, what I'm going to have to do is cross out the 7. I have to make it 2 digits. So same thing, I've got to make the 6 2 digits, the 5 2 digits, so on and so forth. And so then what I would do is go and put those pieces I just cut off, okay, into the correct leaf. So with the 14, since it's a stem of 1, my leaf is a 4. 0 7. 0 6, 0 5, 12 would be 1 2, 3 8. So I actually had the wrong largest value, but we can fix that as we go through. And then what I'll tell people then is the other thing we always want to do is have my leaves in order. So whatever I have, I'm just going to go with the data I have right now. What I'd always want to do is reorder it from least to greatest. One of the big things that we want to do, though, is always have what we call a key. These numbers mean nothing unless I know what they represent. So for instance, if I have a stem of 1 and a leaf of 3, I need to know what does that mean. In this example, it would be a 13. Okay, it could mean 1.3 million. It could mean 0.013. Okay, so the key is important. Sometimes you may have to round off some numbers. For instance, if I have my largest value, or my smallest value is 105, and my largest is, say, 1348. Okay, obviously I don't want to just cross off the last digit and use stems from 10 to 134. So what I would do then is round it off. And so what I'll round this off is to 110. I'll round this off to 1350. So I round it to the nearest 10. And then what we'll do is we'll cross off 2 digits. Okay, 1 to 13, still kind of a large spread, but not as bad as 10 to 134. A couple variations to our stem plots is we can also have what we call a back-to-back stem plot. And what happens there is we're usually comparing two sets of data. So maybe I have a set of data for my males, maybe a set for my females. Okay, we will share the leaves, or I mean the stems, I'm sorry. We'll share the stems, and then my leaves will come off of it. Okay. And then the same thing with the males. Now, it doesn't matter which way you go with the males in terms of your numbers, if you go least to greatest from right to left, okay, or if you go from left to right. Okay, as long as you do the same thing, because what we'll do is we'll use direction-wise, and that's why I put them in order to find middles. We can also split stems. So if you go back to this idea here where we go from, 1 to 13, there's a lot. Sometimes it might be that my stems would go from 1 to 3. Okay, and so a lot of my data would be crammed in here. And so what we can do is we can talk about split stems. I can have 2 stems for the 1s, 2 stems for the 2, 2 stems for the 3. And what I would do is I'd put any 0 to 4 leaves in the top row and any 5 to 9 leaves in the bottom row. Now, the most common way we deal with putting together quantitative data to see it is a histogram. Okay, and so what we look at with a histogram, here's my set of data. Okay, down here is going to be my scores, and here's going to be my frequency. Now, again, the idea is I can put these all together in order from least to greatest. I like to just find the smallest and find the biggest. So it appears that my smallest is 81, okay, and that my largest 145. Okay. Now, sometimes I'll tell people just to start with your smallest one. Okay. In this case, I'm not going to. Okay. What I'm going to do is I'm going to start at 80, because if I can get to multiples of 5 and 10, sometimes it's easier. So I'm going to start at 80. Okay, I have to end up at 145. Now, we're going to talk about bin widths again, and how I talk about finding your bin width is by taking and finding your range. Okay. So in this case, it's 64. Now, what I'm going to do is I want to break it up into some bin width or some range of values that I want to fall into this bin. Okay, and so what I do is I just divide by 7. It doesn't matter, okay, if we get, it's just a number I use. Okay, it's nowhere in a book that says yes, use 7 every time. It just guarantees I'm going to get about 6 to 7 bars. And I don't even worry about exact values. What I know is that's a 9 point something. And so what I'm going to do is I'm going to round it off. Okay, and so this is going to become my bin width. Okay, bin width of 9. Okay, now, really not a great bin width. We can round these off too. So what I'm actually going to do is, it's going to be easier to go by tens because I can count by tens really easy. So 90, 100, 110, 120, 130, and I got to make sure I go past my highest value of 145. Now my process then is I'm going to go and take this value, this 145. So it falls somewhere in between 140 and 150. What I like to do is just put a little block here. Okay, 139, somewhere in here. 126, between 120 and 130. 122, also in there. So I'm going to stack another block on top of that. Okay. So I'm going to pause here a second to finish this up and talk about a little more in a second. All right, so finish it up. Now, one of the ones I want to bring up is this 130. Okay, there's 130. The left edge is included. The right edge, again, we don't include. So what we say is that this bar right here contains all my 130s up to, but not including 140. So any value is 130, at least 130, but up to but not including 140 would fall in there. Same kind of thing happened with 110. Okay, that would fall in here because it's included to the left side. And a lot of times what I'll do then is I'll put down in here how many observations actually fell, because sometimes it's kind of hard to see your vertical axes. And then again, remember how we can go back and put these things in our calculator. This is how I do it by hand, but we also talked about how we could do it with the calculator, which you'll do a lot more of. Now, once we get our distributions together, what we're going to do is talk about describe our distribution, which includes a lot of things. Now, I use this acronym here, SUCS, to remind us what's going on. Okay, 4 things we always want to do when we describe distributions. You want to be able to describe it so somebody who doesn't know what it looks like kind of can get an idea in their head what's going on. So with our shape, we're talking about one of 3 situations. One could be symmetric, okay, which again means there's a line of symmetry that I could fold across, okay, and I'd have the same thing on both sides. Okay. So it doesn't have to be this perfect bell-shaped curve, but we'll get to the situation like that later. We could have skewed. Okay. Skewed simply means we have a tail to it. Okay. Now, might look something like this. This is skewed to the left. Direction of my tail, again, is where I'm skewed to. This could be then skewed to the right. Okay. For instance, the one that's skewed to the right would be something like NFL salaries. You got a few people that are paid a whole bunch, but then the rest are to the lower end. Okay. If I don't have either of those, then we say that we have neither symmetric or skewed. Unusual talks about outliers, okay, something that doesn't seem to fit. And so if I go back to this distribution here for a second, it'd be if I had like maybe an observation out here somewhere. It doesn't quite fit. A lot of times with a histogram, I'll talk about 2 straight bins that have nothing in it. Okay. Now to kind of talk about a shape, since I should have done that when we were here, is what we're going to do is talk about density curves eventually. But if I kind of play dot to dot with the tops, what's going on? You know, I might consider that fairly symmetric. Okay. But we'll never have a perfectly symmetric really, but we can talk about fairly symmetric. Center, and we'll get into this more when we talk about numeric values. Center, we're going to talk about either my mean or my median, depending on which one of these situations we have. Okay. Spread, difficult to talk about when we're just looking at a graph. Okay, but spread means how spread out is it. Eventually we'll get into terms of standard deviation, but a lot of times you can look at is, you know, is it kind of flat or is it just all scrunched together and things like that. So that's the idea of spread, and we'll get into standard deviation and stuff like that eventually. All right, so that's section 1, 2.